Okay, so hi, my name is Paul Belanger. I'm sure you guys know Leif Madsen. He's a big deal. But anyways, today we're going to talk about basically how to automate your infrastructure from the builds to the tests to actually deploying Asterisk using existing open source tools. So what we're talking about today, we've not thought of this concept. We're just kind of gluing all the parts together to make it easier to interact with. But as we talk about it more, you'll clearly see familiar parts. And this is our take on it. I'm sure you guys might have your own take on it, or your company has a take on it. There's no right or wrong way, but if you're doing this, I think you're in the right path to managing your infrastructure. So basically, what is automation? For me, automation is, it's done by computers. It's done by robots. It's not done by humans. And the reason being is computers in that aspect are good at doing the same thing over and over and over and over. Us, we tend to get lazy really fast, or we're tired and it's 2 o'clock in the morning and you just want to get to bed because your customer's site is down and you tend to make shortcuts. Who is it good for? I mean,
yeah, it's basically good for everybody. I mean, it's not just, I mean, we're going to use examples where we're provisioning an Asterisk box and provisioning Polycom phones and stuff, but I mean, really, this is useful in every aspect. I mean, we want to take this concept and apply it to everything so that my entire infrastructure, so actually automating the deployment of the initial building box to even build the RPMs or the deb files or whatever. So that's who it's good for. It's basically everybody.
And why is it a big deal? Well, I mean, DevOps, that's kind of a hot word right now. So it takes the developer and the IT administrator, kind of meshes them together. And I mean, it gets you out faster. It's faster installs, faster deploy, faster testing. And where to automate?
Everywhere.
Everywhere. You know, I mean, from a company point of view, it's probably bad for your employees because, well, you're kind of replacing them. But hopefully they can move to elsewhere to do other things instead of pushing buttons to install an ISO or something along that line.
And I think the big thing is getting to a point where your developers can develop and not maintain systems and perform support tasks and be able to do it at a much larger scale than what you're able to. I mean, how many people here have basically deployed 5 systems and been like, I can't really do any more of those because the maintenance burden is just too high. So I mean, if you think of trying to scale that up to like from 5 to 100 or 1,000 or whatever number of systems to be able to maintain that, being able to automate is the only way that makes sense without having to hire, 1,000 people.
Yeah, we'll skip this. It's about us. So basically, the infrastructure overview, these are kind of the points that we broke out in our heads, and we're not even going to touch all of them just because it's so massive. So we're going to try and get through this relatively quick. I mean, questions, obviously.
Come find us in the Code Zone after, see us around the conference. We're happy to talk about this stuff.
Yeah, because we really want to show kind of a little working demo that we got going here, and hopefully it works, and if it crashes and burns, then it crashes and burns. So basically, automation, Puppet, Chef, continuous integration, Bamboo, Jenkins, CRM, Git, Subversion. I mean, it's pretty straightforward. If you know of packaging software, there's pbuilder, which is Debian-based. There's Mock, which is Red Hat-based. And there's Asterisk, different productions, code review, sandboxing, OSs. So I mean,
yeah. So these are basically the layers we've kind of broken out, and each of these layers has its own integration aspects, and being able to automate even the installation of each of those layers. So we have automation at the top, and say we have continuous integration, whether it's Bamboo or Jenkins. I mean, the installation and provisioning of that Bamboo or Jenkins server is also automated. So each of these things keeps building. SCM is where we're keeping the code that we're actually testing within our continuous integration, and et cetera.
And these, looking at this, you might say, these are individual people's responsibility for doing. What we're proposing is it's all meshed into a single kind of platform or package, or that's a single overview of what we want to accomplish. So again, some just fancy colors. So virtual environments, that's kind of what we're going to talk about today, virtual environments, clouds, but all the concepts apply to directly bare metal hardware. It's just easier for us from a development point of view to spin up VMs than it is to actually go down to a co-location and rack servers. So, I mean, again, it's pretty familiar. Bare metal. Instead of OpenStack, we probably should say virtualization. But, I mean,
we like OpenStack. It's all right.
And then you got your different stages atop of that. Your testing stage, your staging stage, or your environments, I'm sorry, and then your production environments. And the concept of this is that, like, doing it in production is no longer an option. And that's kind of how we went down this path discussing it, is no more are we actually SSHing into a box and making it, even though it's a simple change.
It's not, you don't have it documented anywhere, and it's not applied to all your servers. I mean, I know of, there's obviously systems where I can run one SSH command across a bunch of servers, but the whole point is that that's not easily reproducible. It's not easily maintained. I mean, the problem is that you get into a situation where, Jim Bob went in and logged in and fixed this thing at 2 in the morning. He forgot to send an email because he was tired. He's like, oh, it works. I'm going to bed. He didn't bring it up in the meeting the next day, and it never got documented. And then when the system goes down or it has to be redeployed, it's like, man, didn't we fix that bug? And then it's just that whole thing over and over again.
Or more specifically, there's a deadlock on your second production box that because you manually installed it, you forget how you actually installed it and what libraries you're using. So the concepts that we're using is...
You can easily reproduce it in your testing environment,
Exactly.
The exact same machine that you have in production, because the same tools that you're utilizing to build your production machine is the exact same tools that are being applied to your staging, which is like your release candidate or just pre-production or your development environment. So
again, virtualization, I mean, bare metal is still an option, but from a development point of view, it makes it very attractive, very easy. Most machines have hyper processor capability, KVM. My laptop doesn't because it's a $200 laptop, but start, stop, clone, destroy instances relatively fast. And then different types of, again, levels of virtualization. I mean, you can get into parallel. You can actually get into kind of OpenStack where you're virtualizing across multiple hardware. So if your hardware dies, you can interchange it, live migration. And same thing, VMware, OpenStack, just a couple.
VirtualBox,
VirtualBox.
a million different things.
Yeah.
The virtualization layer doesn't even matter. You just pick whatever you're most comfortable with, and all these tools are going to be able to utilize them because it's just the Linux machine that's built on it.
Another aspect is everything is packaged, no compiling manually. I mean, I know compiling is perfect for single development, but when you're running your production boxes, you don't want to have different flavors of Asterisk, for example. It's just too much to maintain, and it's, the concept of, oh, I've deployed this customer 5 years ago or 2 months ago. I really hope that box doesn't fail because I have no idea what I did when I did it. So the concept here is that you have your packaging source, which kind of wraps around tarballs and so on, which you submit to a build server, something like Launchpad, or you have a local build server, and then you push it to the repository that the actual production boxes or test boxes or staging boxes will pull that down. And I mean, this is just kind of a simple diagram. And then you can get into the fancier stuff where you use your continuous integration tool to actually do all this. And basically have plans when there's ever commits to Git or Subversion, goes through and actually generates all your packaging to make sure that stage passes and that your code didn't break anything.
Changes to your spec file or whatever. You make sure that the package you're going to build is able to package and actually install, and then you can actually run your tests against it. Once that package has been installed, you run a spec test against it to verify that all the files I'm expecting to be installed are installed and have the right permissions and all that stuff. You make sure that you basically take the burden off the developer almost, in that you are able to say, this is what I'm expecting to have happened, and it is what has happened.
Yeah.
And I know immediately, as soon as I make that change, I don't even have to push it to production. The system is just going to send me an email 20 minutes later, or whatever the case may be, and say, yeah, you screwed something up.
And honestly, a developer doesn't care about packaging. They care about writing code. And for them to go out and learn how to package something in Debian packages or RPMs, it's just another thing they got to learn. And it's just, if Leif is the guy that knows that and he leaves, then we got to train somebody else to do all that. And it's not fun learning it if you don't know it.
And once you've done it, who cares? I mean, like once you've got it done and you can automate it and bring it up, I mean, you move on. Go back and develop the things that your customers want. Like, they don't care that you're using packages or whatever.
Yep.
Get it up and done. It's automated. You can build through it. And if all those boxes die and go away, you just spin up new ones because you've got it all scripted, essentially.
And basically, everything is in a CH root, and this is how Linux distros work. This is the concepts that they use. So if it's good enough for a distro that you're running your software on, it's probably good enough for your application that you run on the distro. And build once, deploy many times. Again, how long does it take to compile Asterisk? Okay, maybe 5 minutes, maybe 10 minutes. It's really CPU dependent. You could fork, get G8 or whatever, J8. But imagine if you have 100 sites and it takes you at least 30 minutes just to compile. I mean, that's a lot of time when you could just submit it to a single system and then it's deployed to many.
And I think the main thing is just that once you package it, it's significantly easier to perform automated testing against it. That's the primary reason.
So faster, cleaner, and again, Debian and Ubuntu have deb files, Red Hat, CentOS have RPM files.
Same
Two
thing.
different things, they do the same thing. Personal package archives, basically this is just a web server, SSH server, some sort of server where you push your packages to. FTP, HTTP, SSH, you can have access controls, public keys for SSH, both public and private repos. That's what I use for customers. Public side is all the Asterisk infrastructure. All the private stuff is my IVR applications or maybe custom prompts or something along that line. And again, Apache and Rebuild D are tools, but basically you're looking at something like launchpad.net, which is what Canonical and Ubuntu uses. Automation software, how are we doing on time?
No, we're good.
So basically, I'm sure everybody has Bash and SSH scripts. I mean, that's automation.
That's the old and busted.
Yeah, that's old and busted, But Chef, Puppet, and Salt Stack, excuse me, they've kind of made it generic enough so that a collection of scripts can be shared or modules can be shared between them. So, Leif and Cordile are big on Chef. Myself, I'm big on Puppet. They do the same thing, same concept.
Yeah.
It's just syntax.
It's mostly syntax.
So
the primary difference is Puppet has a nice structured language that makes it easy to kind of get up and running, and it kind of forces you into thinking correctly. Chef, you can get yourself into a little bit more issues because it's straight up Ruby so you can almost think of it as AGI versus dial plan, kind of idea.
Yeah, they do the same thing.
Do the same thing, same concepts all apply.
And so again, this diagram we were trying to show is that from the workstation, you're pushing all your code and all your changes to source code management. And then there's a mechanism here we didn't describe, maybe continuous integration, that will tell your DevOps server, either Chef or Puppet, the Puppet Master, to notify your nodes to go out and do something. And it could be a simple password change for root, or it could be more complex, which we hope to show here, is that to actually go out and mass provision Asterisk boxes with Polycom phones.
The provisioning, the configuration, the registration, all the things required in order to bring up a brand new Asterisk box and attach your phones to the network and have them configured and provisioned from a centralized location, as opposed to modifying sip.conf manually across all the servers. You basically modify your manifests or whatever the case may be and tell it about that from your workstation, push it up to your GitHub or Subversion. Your continuous integration basically goes through and tests all those changes to make sure you don't have a syntax error or that things are actually working. And then once that gets pushed down through all the testing, that gets pushed down to the nodes, and it's going to work because your continuous integration environment directly matches and mirrors your production environment, which is the main key of this whole thing, I think.
Yep.
Did you start the?
Yeah, that's why we're heavily dependent on the web, so we're kind of aligning things up here just to make sure, and to save time. So source code management, everybody either who uses Asterisk or develops with Asterisk, or any hopefully project that you do, you guys use this. But at the same token, you want to put all your custom dial plan logic or your, anything that somebody is changing human-wise, you want to put it into the source code and have some sort of code review process or even unit tests against it. I mean, even if it's a simple dial plan to change the caller ID, you could write Asterisk dial plan that you could invoke a local channel to just make sure Asterisk
actually set what you expected.
Yeah, exactly. Rather than upgrading your production box and then firing an email off or getting on the pound asterisk and saying, oh, something broke. Okay, well, did you test it first? I mean, I know the project in general does testing, but it's just so massive, you can't rely on the project to do that. You have to take some of the responsibility being a customer, an integrator, your customers. You have to do some testing yourself.
And you obviously know what your deployment looks like and what is the most important to your customers and what to be checking and testing and making sure that things work. I mean, that's the whole point, is that you have all the control to be able to make sure that everything is going to be running nice and clean for your customers.
So again, an example, you do all your work in development, you move it to staging, and then eventually you move it to production. The concept is you never go from development to production, or you never commit directly to production. You could commit to staging and then move it to production. Maybe it's a simple bug fix. But yeah, I mean.
So basically here, this is kind of showing where your development, on the development side, is like your daily and multiple commits. So I'm working on stuff, I'm committing it, I'm sending upstream and getting that ready for the next release. And that's going through and making sure that all the testing looks okay. And then at some point, you need to deploy that, right? So you have your staging environment, which you could think of like as a release candidate or something to that effect, where you have made a snapshot, and this is what I'm testing, making sure all those tests are working, maybe even have additional tests within that. You would also be doing things like manual tests. So I hooked up a phone and I actually ran calls through it and made sure all that's working and following my scripts. And once that's all done and I've made whatever changes within that snapshot, which is the more minor version, then eventually you can push that down and that goes into your production. And you know you've done all your testing. You know that you've exactly what you're deploying to all your servers, and all the servers are getting the exact same thing at essentially the exact same time. Or you can obviously spread it over whatever period of time, especially with Asterisk, right? The downtime, and if you have servers, servicing people across different time zones and stuff, you can stagger it obviously, but that's the main concept and the main workflow that you want to do. On the development is your quick development, staging is like a slower development cycle where it's more your release, and then your production gets what just came from staging.
Yeah, so we're just going to kind of quickly just kind of start this and then continue on. So imagine, just due to constraints of networks and so on, this is heavily dependent on the web and your network infrastructure. But imagine that we have just from a single button pushed it and it's created our virtual environment. That's what this shell represents. And you utilize a tool like Cobbler or something. And then once the image is booted, it actually will go out and register itself to your DevOps or your Puppet server in this case, to then proceed to basically run this command, which what it does is, you can see, it's hard to see, but I'm pointing it to a public Puppet server on the web, which hopefully we can connect to and get our kind of manifests.
It looks okay so far.
And so far it's working, but apt-get is updating, adding apt repositories, adding in SSH keys for those repos, and then, we pre-cache some of the files to speed up the downloads, but it goes out, grabs the latest and greatest of everything. So I'm going to flip back, and hopefully when we come back, we're going to see some blue and green, which kind of indicates that it's working. So far it looks good, and I think we can flip back. So again, another point, we're down to about 13 minutes here, so we've got to speed up. Continuous integration, again, it's a tool that basically just does the same thing over and over. Asterisk project, we use Bamboo, which goes through, and as we commit changes into trunk, it will then go out and launch testing instances. We use Jenkins because I think
it's easier for our type of integration.
Yeah. And then it's kind of the core piece. It's the piece that everything is built upon. And it's good at doing the same thing over and over and over. And again, so there's Jenkins and there's Atlassian. And I don't really have much time, but the guys at OpenStack, specifically HP, they got this really cool piece of software that they wrote. It's called Zool, which I'm trying to package up, which actually will actually create Jenkins plans through automation. Like, you don't have to manually log into Jenkins to create your plans. you create them in YAML files, and it's this whole concept of trunk gating, that no code actually gets into your source code before it passes all your automation testing. Like lint, make sure your code is formatted properly, that it compiles, that manifests actually compile, that things load. I mean, it's a really slick interface, and that's one thing that the OpenStack guys, well, not one thing, but one of the main things that attracts me to OpenStack is just their infrastructure for testing. And it's just the guys at HP that have just done it.
Yeah, essentially nobody pushes into trunk or into a release. It's actually the software that's making that happen. So the developer is pushing into development, and then they're maybe triggering when it's going to be into a release, but that release itself is actually created essentially by the computer.
Yep, and it's a code review tool, and really no single person commits code. It's all done by a bot, which then takes responsibility of merging it, and yeah, it's really slick.
All you're doing is coding and pushing it up and letting the infrastructure handle all the merging and the control and everything, and then the people who are doing business aspects can basically control when they need to do the release based on your Scrum or whatever the case may be.
Yeah, and it makes it really easy for new developers to come in because they don't have to carry or worry about how to merge, package. They just need to make sure that their local code passes their local unit tests, and if it doesn't, Jenkins will email you and say, hey, there's a problem, and this is exactly where the problem is. And again, code review, we use review board. There's Garrett for Git. GitHub has kind of got its own code review system.
Yep.
Again, this is kind of the only real human aspect that's still in it, aside from the development of the code. Users code review it. You can pull down. I mean,
and then based on your code review, you know what things you're catching and what automated tests to build, so that basically you can catch it going forward type thing.
All right, so I think we got 10 minutes left, and hopefully this works. So these, it's hard to see, but this is actually the source code to the demo that we've done. So this presentation was kind of packaged up from a Debian point of view. So the demo is Ubuntu 12.04. We're using Puppet. We got some Polycom phones, and basically we've just spun up an instance, and we're going to mass provision these phones. I mean, they're not working right now. We just formatted them. And again, hopefully you take our word that it was an empty VM. I mean, we can show you, but...
Well, and all the things that Paul's been working on, especially for over the last 9 months, is available on GitHub, and you can basically start working with it. The whole point is to be able to have these scripts and things and build them up in an open source format so that people can contribute and utilize them within their own environment, and then continually spin that up and make that larger so that other people can start utilizing it to deploy infrastructure. So you can pick and choose the things that you want to actually do.
Yeah, so we'll go through this kind of quickly. So here's the source code. It's kind of broken up to Asterisk specific. Debian is for packaging. Puppet is for the Puppet manifests. And basically, extension, the way that I envisioned it is it was actually based a lot on include files. So, I mean, internet's going to work on this example, but it actually has extensions.conf, and it's got a very minimal dial plan, okay? But if I make a change here, it goes through a code review process, and then it gets packaged automatically. And here's my instance of Jenkins that you can see I've already done 16 builds, and basically a lot of this was done at DevCon. So as we were demoing it, we found problems, and you can go through our commit history and see what problems we ran into.
We found issues and fixed them for the demo specifically, and we're able to automatically test to make sure that they were valid in other testing in scenarios.
So this is kind of Debian's packaging. Again, we won't get into it. Post installs, directories, but it's generic enough, the way that I envision it, it's going to be generic enough for anybody to kind of use it, and once asterisk extensions.conf changes, it will be smart enough to go through and reload your dial plan for you without you logging in to reload it.
So while that's running, you can just load it up and we just take questions.
Yeah, so basically, oh, it's done.
Nice.
So I'll scroll back here, but
I'll reboot
green and blue is good, but all these are actually function calls into Puppet manifests that basically we've created.
So you can see, like, there was, if you scroll back up, so there's resfax there, exprov.conf. These files are basically all being copied in and configured and provisioned and set up for this Asterisk instance that we're building right now.
Yeah, so that's the Polycom, firmware files and so on and so forth. So basically now, if Leif goes and reboots this,
yep.
Oh, and it provisions DHCP too. Like DHCP was provisioned, all the XML files were generated. Asterisk was installed. All of our custom configurations were pulled down because we packaged them. And basically, once it stops, I don't want to kill it.
Nice. So you can't see it, but at this point, this phone's now loading the application and provisioning itself from this instance we've got loaded. So yeah, I'm just going to put the mic over in this stand here, and people can just ask questions. Is that okay? Like, can I use this other mic up here, or I'll just talk into Mike's or Paul's lapel?
Yeah, I mean, so hopefully that, kind of makes sense the way that we've done it. But a lot of this stuff we've open sourced it. It's up on GitHub. So for you to actually use it, and again, we're heavily dependent on web stuff. It's just a couple lines in Puppet that will say, I want this extension with this MAC address and these settings. And then it just utilizes the Puppet manifests that have been published all on the web to actually provision your box. So the web is working somewhat.
Yeah, so basically you can repeat what I'm saying. But basically I can make now a call from 3001 to 3002. And then we basically have a phone up and running, and it's all provisioned. That was from scratch from a formatted file, and it took, I don't know, 5 minutes?
Yeah, it would take a couple minutes. We kind of preloaded stuff for, obviously you're dependent on network access, right? So you can see here, this is just a simple text file that basically says, okay, we want Polycom provisioning, this is our password, our Puppet server, our TFTP options. We've gone so far as actually specified the network interface, the IP addressing that we want. And these are kind of the little scripts that we've built for this specific install. Asterisk server is kind of a public module that we've pushed upstream or on Puppet Forge. And then, yeah, so we say, here's our DHCP, and these are kind of the settings we want. And through that, through the magic of Puppet, it actually goes through and provisions it all. So I no longer have to worry about dealing with XML files for Polycom or DHCP settings or something along that line. It's very modular in that aspect. So and you can see, so here's 3 phones. There's myself, Russell, and Leif. 3 MAC, everything is MAC addressed, obviously. And we, when we specify your email address, it actually will go through and generate the voicemail.com for that email address. And extensions and full names, secrets. It's the raw secret file here, but we use MD5 sums in Asterisk. So if somebody was to look at the config file, it's all, kind of using native Asterisk functionality. And then, I'm just going to kill this. Hopefully it works. It clearly does.
Yeah, I made that call.
And there's our peers. It all did it as we were talking. And I know but we developed it in Ottawa and Toronto offline. We came here, fired it up on the hardware, and again, because of network requirements, it took 5 minutes to do. Which is pretty good. If you're doing it faster, I would love to talk to you, because that's as fast as I think I've come up with.
So if anyone has any questions, there's a mic here that I set up in the stand so that it's good for recording.
Yeah.
Other than my answering.
So there's
I'll answer on the mic.
yeah.
I can just carry the mic around. Yeah, you can do that.
Are you using any tools for actually dialing into your Asterisk systems and going through the dial plan to test out functions that way?
Well, there's the test suite, the Asterisk test suite that we utilize, or SIP-P along that. We didn't really get into it in the demo, but as we launch this, there's also a whole monitoring infrastructure that we've brought up with Nagios. Our sync server, or our syslogs have been created to push logging to a centralized server so that either myself or Leif can kind of log in and kind of monitor all of our customers. So we just didn't present it here, but it's heavily kind of ties into the Jenkins or the continuous integration level, is that whenever we would do a dial plan commit, maybe we want to make sure that the dial plan is formatted correctly, or we've written some dial plan tests already in the test suite, and we want to launch that whole test suite infrastructure against it. So yeah, we do that. It just wasn't presented here, just because it's just so massive. So hopefully that answers your question. Anybody confused? Like, was it clear as mud? It's a lot to get over. I mean, it's really massive. But there's a lot. My goal was to kind of explain there's a lot of existing tools out there to do this, and all we've done is just kind of glued them together so you can bring up this infrastructure really simple. You don't have to go out and write all the modules to bring up Jenkins or to bring up Asterisk or to bring up DHCP or Polycoms. I mean, to do Digium phones, for example, it would just be a matter of understanding how the Digium phones interact with Asterisk and just kind of exposing what changes you wanted to change on a per user or a per global level.
So I can even elaborate on like what we've done at Cordal recently with using Chef is we've utilized Vagrant, which is just a virtualization trigger essentially to load up virtual machines via VirtualBox. VirtualBox being the virtualization platform. And what happens at all the developers have their own box essentially with like say 32 gigs of RAM or 16 gigs of RAM, and while they're developing, they actually have to spin up an entire instance of our platform, which is provisioning server, 3 different feature servers, fax server, API server, web interface. All of those things need to be spun up, and every developer essentially has the entire production system on their single box in obviously a smaller format, but they're able to reproduce and develop against the production system exactly as it'll be deployed. So when they have to perform their demos for the project owner, what happens is they actually have to spin that up from scratch, which takes about 55 minutes or so to spin up all these boxes and provision them and utilize from their own branch. And then they have to demo to the project owner those changes. So it's a very controlled format, and the project owner feels very confident when he sees what he's seeing that how it works and how it's going to be utilized in the demo is exactly what his customer is going to see in the production environment. So just being able to do that, as opposed to the previous method that we had was having a lab box that all the developers would log into, and it would essentially keep progressing over time. And obviously, if you keep progressing that over time and making changes and tweaking with it and doing your development against it and not being able to tear that down and rebuild it from scratch and apply your changes, well, you've got changes on there that look like they work, but as soon as you go to apply them to your production system, the production system is entirely different. No. So this is a method that we've employed recently to allow us to make sure that exactly what we're doing in development is exactly what's being deployed to production.
So I think we're out of time. So that's it. More than happy to answer questions if you got questions. If not, we'll take beer. So. Okay, thank you.